Good morning, everyone. Good afternoon, good evening, in fact, everyone, and welcome to this lecture. We are into electrostatics and we were dealing with electric field. In the previous class, we had seen what is electric field. What is electric field? Huh? What is electric field? It's a region in space where a charge experiences electrostatic force. Do we remember this?
Yes, sir.
We had also found out the intensity of electric field at any point. If you want to find out the intensity of electric field, you find the force on a test charge and you divide it by the value of that test charge. Yes or no?
Yes, sir.
We had seen the electric field due to a point charge, kq by r square. Yes or no?
Yes, sir.
We have also seen the direction of electric field due to a point charge. Due to a point charge, it is always along the line joining the charge with the point. Yes or no?
Yes, sir.
Then, due to a positive charge, electric field is going away. Due to a negative charge, electric field is coming towards. We remember this, yes or no?
Yes, sir.
Okay. Then we had seen that a positive charge will experience force in the same direction as electric field. A negative charge will experience force in the opposite direction. If you have more than one electric field, the net electric field will be the sum of all the fields. Yes or no?
Yes, sir.
And then we were doing this question and no one gave me the answer for this one. So again, we have to start with the same question. So this was a question that we were discussing. We had a negative charge of some mass and we are supposed to balance the weight of this charge using electric field. So again, we start with the same question. What is the value of the electric field that can balance this charge? So I'll give you 2 minutes to solve this one. A simple question based on simple concept. And I'll give you 2 minutes to do this. And I hope everyone does this. Anyone knows the answer? I asked you what is the direction of electric field. Can you tell me what is the direction of electric field? Upward, downward, sideward, leftward, rightward, where? Now remember, to balance this weight, I must have force in the upward direction. Yes or no?
Yes, sir.
This is a negative charge. To have force in the upward direction, in which direction we should have the field? We should have field in the downward direction, because negative charge will only experience force in the opposite direction of field. Do we understand this?
Yes, sir.
Now, how do I balance this? If the electrostatic force F equates the weight, then this charge would be balanced. The value of F is Q, the charge, multiplied by E. So Q multiplied by E will be equal to mg. So I can say the value of electric field will be mg, weight of the body, divided by Q. Do we understand this? Yes or no?
Yes, sir.
So this was the answer that I was looking for. I hope we have understood this. Yes or no?
Yes, sir.
Please note this down and remember such questions. Have you noted it down?
Yes, sir.
Then comes the next question, a variation of the same one. I'll give you 2 minutes to solve this one. Yes. Do we have any answer for this one? Now this question requires calculation. So let us not get into calculations, and let me tell you how to do it. You already know how to do it. Yes or no? Yes or no? Shall I do it? So you have to balance this electron, and you have to balance it by the electric field of another charge. So this is the first diagram. To balance it, we need an electric field in the downward direction. Yes or no? Yes or no, bacha? So the value of this electric field should be equal to mg divided by the charge, and the charge here is the charge of an electron divided by E. Yes or no?
Yes, sir.
Now this electric field has to be produced by a point charge at a distance of r. So if you have to see the diagram, here is the diagram that is coming. So from there you can understand. You can understand this diagram. So I'm producing this electric field by this point charge. Do we understand this?
Yes, sir.
This point charge is going to produce this electric field. So this electric field will be equal to 1 by 4 pi epsilon naught into the charge is E because it is electron divided by R square. From here I can find the value of R square or R. The value of R square or R would be how much? We can calculate it. Yes or no?
Yes, sir.
It will be equal to E square divided by 4 pi epsilon naught mg. So if a very tough question comes, you can solve it in this way. Do we understand this?
Yes, sir.
This is the question of electric field. Anyone got this?
Yes, sir.
Okay. Now, before going any further, what we have to do is, now the most of the question that you are going to do in this chapter will be either on point charge. Now remember, I also told you that whatever questions we had done for electrostatic force, there are also the questions of electric field, yes or no?
Yes,
Before
sir.
going any further, let me ask you this question from the previous question, and I'll take you to the previous question only. Let us say this question. Do you remember this question? 5-point charges of equal value Q are placed on the vertices of a hexagon. 5 charges are put and 1 charge is not there. Do we understand this?
Yes, sir.
And now I ask you, now I have, as you see, I have removed this charge from here. Now I ask you, what is the electric field at point O? What is the electric field at point O? I'm not asking you the force, I'm asking you the electric field. What is the electric field at point O? And your answer is what is the electric field at point O? And the answer is you don't know the answer?
KQ by R square.
KQ by R. Here it is given as L. KQ by L square.
KQ by L
The
square.
pink charges electric field will cancel out each other. The green charges electric field will cancel out each other. The only electric field that will remain will be because of this charge. Now this is a positive charge, so electric field will not be going in this direction. The electric field will be going in this direction. Do we understand this?
Yes, sir.
And the answer will be KQ by L square. Do we understand this?
Yes, sir.
Yes, sir.
Now I ask you the same question here. I have removed the charge here. The charge is already removed at point A. Now I ask you the same question. What is the electric field at point A? What is the electric field at point A?
By alpha square.
Yes? The side of this equilateral triangle is A. What is the electric field at point?
A square.
So the value of electric field will be root 3 k q by a square. Do we understand this?
Yes, sir.
Yes or no?
Yes, sir.
Everyone understands this? Yes or no?
Yes, sir.
Okay. That means whatever questions we have done for electric field are also questions of electric force and vice versa. That means whatever question we are now going to do for electric field are also questions of electric force. The only difference is we will have to put a charge. Do we understand this?
Yes, sir.
Now we'll have to find out and remember and write the electric field produced by different type of charges in the normal form, in the vector form you may not write, and you must also understand their graphs because they can ask you a question based on these graphs. So let me, okay, before going on to this, let me show you the graphs of two types of charges. First, this question can come. I mean, where is this? I'll show you, and I've seen questions are based on this in your NEET exam as well as in JEE. So I'll show you these graphs and these diagrams, and you just note down how the electric fields are. Okay. So this is graph number. This is diagram number 1. Electric field lines due to two positive charges of equal magnitude. If there are two positive charges of equal magnitude, this is how the electric field lines will look like. And it is very easy to understand why they are like this. They are equal charges, therefore at the center point, electric field is 0. Do we understand this? So this is the electric field created by two charges of equal magnitude. This is how it will look like. You can get a straightforward question based on this. Do you understand how it is drawn? At the center point, electric field is 0 because both the electric field will cancel. We understand this?
Yes, sir.
Okay. This is the graph for two positive charges. I will also show you the graph of two negative charges so that you can draw both of these graphs. This is the graph of two negative charges. Same thing, but the only difference is the quadrant getting changed. The graph of two positive charge, you can see how it varies, in which quadrant it lies. Graph of two positive charges, it lies in all the four quadrants, but then you see how these quadrants are varying. In case of negative charge, again it comes in all the all the four quadrants. As you can see, the orientation of the quadrants have changed. Please note it down. I'll give you 2 minutes to do it. These questions will come straight away.
Done, sir.
Everyone?
Yes, sir.
Okay. These are the graph of two charges which are equal in magnitude. Now let us move on to charges which are unequal in magnitude. First, let me explain what is the difference, and then you can draw them together. Just give me a minute. Let me try to make you understand the difference so that if they change it from one place to other, you are not confused. So here are the graphs for unequal charges. What you are supposed to understand here, see, this is the positive charge. Positive charge here is more powerful than the negative charge. The negative charge is the green charge. Positive charge is more powerful, therefore the value of E is equal to 0 happens behind the negative charge. Do we understand this? When the charges were of same dimension, I mean same sign, the E will be 0 at somewhere in between. But when the charges are of opposite signs, the value of E would be 0 either on this side of the charge or on this side of the charge. Do we understand this?
Yes, sir.
Now, you can see here on the other way, the smaller charge is positive and the bigger charge is negative, and therefore the value of E is equal to 0 comes here. Do we understand this? So it will always come behind the charge of smaller magnitude. If they have the same sign, it will come somewhere in between. If they have opposite sign, it will come on the other side of the smaller charge. And that is how you can understand. You will not be supposed to draw this. What they will give you is they will give you 4 diagrams and they will ask you which is the correct one. So this is the thing that you can see there. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down.
Done, sir.
Everyone done, sir?
Yes,
Boys,
sir.
sir?
Yes, sir.
Okay. Now what we'll do is we will move on and write the formulae for electric field created by various type of charge distribution, and you will have to remember these, because if a question comes, it will be based on these formulae. So we'll start. You don't have to remember the vector equation because the vector equation may not come. Don't have to remember the vector equation, but you will have to remember the formulae. Okay, so the first one we already know, that is electric field created by what? By a point charge. So this is what they have drawn, a point charge, bacha. It is a positive charge, and therefore electric field is going away. The vector equation is written. The scalar equation is kq by r square. You may not write this note. Note is not important. What is important for you is this graph. Do we understand this? Yes or no?
Yes, sir.
Okay. I'll give you one more so that you can write both of them together. This is the electric field due to a point charge. The next one is electric field due to a infinite line charge. Now you may not ever get a question on infinite line charge, but you must remember the direction of field and the formula, and this is the direction of field and the formula. Here you might say, sir, what is the value of this lambda? This lambda is current per unit length. This lambda is current, oh sorry, not current, charge per unit length, Q divided by L. It is known as linear charge density, and the formula for electric field is lambda by 2 pi epsilon naught R. Where what is R, bachon? R is the distance of point from the line charge. And as you can see, this is the direction of field. Do you see the direction of field here? On this side, the field is going here. On this side, the field is going here. Do we understand this?
Yes, sir.
And this is the graph. Q is given as linear charge density. R is the perpendicular distance. Everything has been explained here. I'll give you 2 minutes to note this down. Everyone understands this? You will have to remember this. You might not get a question ever because the question is not a part of your domain. I mean, they will come only in JEE Main or maybe JEE Advanced. But you have to remember the formula. They might just ask you. How will they ask you? They will give you a question. Infinite field due to an infinite line charge. Then they will give you 4 options. Inversely proportional to R, inversely proportional to R square, directly proportional to R, directly proportional to R square. You have to choose the right answer. What is the right answer? Inversely proportional to R. Do we understand this?
Yes, sir.
This is how question would be asked. Not a numerical, but a theoretical question. Have you noted it down, bacha?
Done, sir.
Boys, sir. Where are we, sir? Huh? Comes the third one. Infinite sheet. Infinite sheet. Now, infinite sheet and infinite charge may look, infinite line charge may look different, but infinite sheet means it's a sheet like this. Do we understand this?
Yes, sir.
Infinite means it is infinite in this direction and it is infinite in this direction. Now, this type of field has sigma, which is known as charge per unit area. Total charge divided by total area, and the value of electric field is sigma by 2 epsilon naught. Remember, this is the only type of charge which produces uniform electric field. So don't forget it. Uniform electric field. You can see the graph. It is uniform electric field. Electric field is uniform. So they can ask you, they will give you a thin sheet and they will ask you on what factor does the field of this sheet depend on. Directly proportional to x, inversely proportional to x, does not depend on x, inversely proportional to x squared. Then you must remember that it's a sheet and it creates a uniform electric field. Do we understand this, or this has gone above what I'm saying? Bye bye, bye bye, I'm going. Don't worry about me.
Understood, sir.
Hmm. Return this. Then the next one is uniformly charged ring. Remember, wherever we are drawing this electric field, we are drawing it with because of a positive charge. Since this is a positive charge, therefore field is always going away. If this charges would have been negative, field would be coming towards. Do we understand this? Yes or no? No, yes.
Yes, sir.
This is the formula for electric field. You will have to remember it. I don't think whether this formula can come. But what you have to remember more importantly is electric field at the center. You can see this center, yes or no?
Yes, sir.
Electric field at the center is zero. Zero. At the center of the ring, electric field is zero. And there is one more thing. At R by root 2, the electric field is maximum. So you will, if you just remember these 2 points about the electric field of a ring, that is good enough. The actual formula may not come, but this formula you should be able to remember. Have you seen this formula before? I came to know that this electric field has been covered for you. It was not covered. Yes or no? Was electric field covered previously? Okay, forget. Have you noted this down?
Yes, sir.
Then comes, now this might be slightly confusing, so please listen to what I am saying. This is a, this could be a hollow, conducting or non-conducting sphere, or this could be a solid conducting sphere. Now, if it is a hollow sphere, it has got nothing inside. Charges will come on the outer surface. Do we understand this?
Yes, sir.
If it is a conducting sphere, even if it is a solid sphere, charge will only come on the outer surface. For a conductor, charge always comes on the outer surface. So this formula is valid for all conducting spheres, whether they are hollow or whether they are solid, but it is only valid for a hollow non-conducting sphere, because for a solid non-conducting sphere, charge will also go inside. Do we understand this?
Yes, sir.
Now this formula is exactly same as formula for a point charge. For distance more than the radius, the electric field becomes kq by r square. It is exactly same as point charge. Do we understand this?
Yes, sir.
Inside the sphere, inside is the electric field is zero, and therefore you have the diagram like this. Electric field is maximum on the surface of the sphere. The answer is kq by capital R square, where capital R is the radius of the sphere. Do we understand this, or it has gone above our head saying bye 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 bye, I'm going, don't worry about me, I'm out
Understood,
of
sir.
here? Since you have done this in the same breath, I will tell you, without taking another breath, I will tell you the formula for a non-conducting sphere. For a non-conducting sphere, outside the sphere, the formula is same, kq by small r square. But inside the sphere, since there is charge, the formula is different. Electric field inside the sphere will be kq by capital R cube multiplied by r. That means inside the sphere, it is directly proportional to r, and therefore you have this straight line. Do we understand this?
Yes, sir.
At the center of the sphere where r is 0, electric field is 0. This is the graph, a very important graph. This graph has come in JEE many times. In NEET also there was this graph. Remember the difference between the upper wala, the upper one and the lower one. The upper one, the lower one is non-conducting sphere. Apart from that, if it is a conducting sphere or a conducting hollow sphere or a non-conducting hollow sphere, the formula is as there in the first case. Do we understand the difference between them?
Yes, sir.
I'll give you 2 minutes to note this down.
Completed, sir.
Anyone completed? Okay. Now, having done that, we have seen the electric field due to different types of charges. Let us look at some questions now. Or instead of looking into questions, we'll do the question because we don't have enough time to do the questions today. So we will probably deal with the questions in the next class. Now, without we'll be doing questions in the next class, don't worry. Let us go about and see the concept of this electric lines of force, because this is a small concept. We can do this. You can have a question based on this electric lines of force. What are these electric lines of force? Everyone has heard about this term, electric lines of force? Or electric field lines? Have we seen this concept of electric lines of force or electric field lines? Anyone? Now, these electric field lines or electric lines of force, they are imaginary lines. These are imaginary lines drawn in such a way that tangent drawn at any point gives the direction of electric field at that point. Gives the direction of electric field. So these are imaginary lines drawn in such a way they are not real lines, but these are imaginary lines which are drawn in such a way that the tangent drawn at any point will give us the direction of electric field. These are the electric field lines coming from a positive and a negative charge. What you can see is these electric field lines are drawn in such a way that they are giving the direction of electric field. So from a positive charge, they are always going to away from the positive charge, and they are always coming towards a negative charge. Do we see this? So they are always going away from a positive charge, and they are always coming towards a negative charge. Do we understand this?
Yes, sir.
Okay. Have you noted this thing down?
1 minute, sir.
Okay, I'll give you time to note it. 2 minutes. Have you noted it down, beta?
Yes, sir.
Okay, I think we are still out of time. So let us try 2 or 3 properties. The first one is these are imaginary, yes or no? They
Yes,
can
sir.
never cross each other. They are not in closed loop. When I say this, that means they start from positive charge. They have a starting point. They start from a positive charge and they end on a negative charge. Do we understand this?
Yes, sir.
We say that they are not in closed loop. They start from a positive charge. They end on a negative charge. Do we understand this?
Yes, sir.
Okay, the next point that you will write is this one. Tangent drawn at any point gives us the direction of force at that point. Electric field, the direction of electric field will be tangent to any point. So if I just show you here, these are electric field lines. So at this point, the direction of electric field would be like this. At this point, the direction of electric field would be like this. At this point, the direction of electric field would be like this. At this point, the direction of electric field would be like this. Do we understand this?
Yes, sir.
Okay, so just write this. We will continue with this in the next class because there are some more properties left and I want to cover them nicely in the next class because I have seen question based on this in your exam. So we will continue with these properties in the next class. You have noted down this one. I'll give you 2 minutes to note it down.
Done, sir.
Note it down, everyone, sir. Everyone has noted it down? Okay.
Sir.
So we'll move ahead from this in the next class, and in the next class we'll also be solving some question based on the electric field produced by different type of charges, and we will concentrate ourselves on the type of question that are coming in exam these days. Take care. Have a nice day. God bless you all.
Bye, sir.
Bye bye.